How are we supposed to teach students how to read if they can't even fit inside the building? Well, there's a classic line from the movie Zoolander. I don't know if you've ever seen it before. It's a pretty crazy movie. But this is the actor from this movie this is Ben Stiller looking at a scale model of a school, and he didn't understand it. But that's what we're doing in this section 7.2, about similar polygons. Focusing on the goal, I can identify and apply similar figures. In other words, we're dealing with scale models. So that's the goal for today. All right, a couple vocab terms to get us started here. Similar figures, what are they? Well, they're figures that have the same shape, but not necessarily the same size. Uh, if we're talking about congruent figures, congruent have the same shape and the same size. All right, scale factor. Actually, you know what? Let's just draw a quick picture here of a similar figures. That and that. Well, it might not be perfect, but you can tell they look similar. Same shape, not the same size. We're going to assume that they have the same scale factor. That scale factor is a ratio of corresponding linear measurements of two figures. So if the ratio of this is 1, this is 3, the scale factor would be, um, depending on if you're going bigger or smaller. If you're going bigger, it'd be 3 to 1. So it's 3 times the size. If you're going smaller, it'd be 1 to 3. In a scale drawing, then finally, if you're into art, I'm sure you've learned this before. If not, I hope you will. In a scale drawing, all lengths are proportional to their corresponding actual lengths. So you're taking an actual thing and making a scale drawing or a scale model of it that is proportional. All the corresponding parts are proportional to the actual one. So let's get started here. Something that's important to understand here, the essential understanding for this lesson, is that ratios and proportions can be used to decide whether two polygons are similar and to find unknown side lengths of similar figures. All right, we can abbreviate is similar to with a specific symbol, and that symbol is like a little squiggly. All right, it looks like the negation symbol when we're talking about conditional statements, and they are pretty much the same thing, but that's similar. So if we look here, key concept, not a theorem, but a key concept. It says two polygons are similar polygons if corresponding angles are congruent. So if we're looking here, angle B and angle H, they have to have the same angle measures. So if they're similar, they have the same angle measures, and if the lengths of corresponding sides are proportional. So we look over here, we have all the congruent angles, but then we have right here the corresponding parts. So AB to GH would have to be, that proportion would have to be equal to BC to HI, to CD to IJ, and to AD to GJ. All right, that's an extended proportion showing the ratio of, or the proportion that would be for all the side lengths. All right, so scale factor, that's what we just talked about. A scale factor, bringing it back again, is the ratio of the lengths of corresponding sides of two similar figures. So if we look at this, it says what is the scale factor of triangle ABC to triangle XYZ? So we're going to do the second one over the first one. So we're going to go from the bigger to the smaller. It'd be, let's try the corresponding parts. AB and XY would be 6 to 15, which would reduce down to 2 to 5. So that would be your scale factor. From ABC, it's 2/5 because it's getting smaller. So if you multiply any of those parts by 2/5, you'll find the smaller one. We can check this one as well. 8 over 20. If you reduce that, that would be 2 to 5. So same thing. Same thing if you did 10 to 25. All right, now if we did it backwards, it would just be opposite. From XYZ to ABC, you go opposite. So we're going to get bigger. So it would be 15 over 6, which would be 5 halves. All right, that's scale factors for you. So, a couple examples. This first part says, list all pairs of congruent angles and the extended proportions that relates to corresponding sides for the similar polygons. So we know that polygon ABCD is similar to WXYZ. So angle A has to be congruent to angle W. Angle B would have to be congruent to angle X. So now sometimes they're not always going to be in the same direction, so you might have to look at the letters that correspond. So we can just look at here. We know that angle B has to go with angle X. We know right here angle C would have to go to angle Y. And we know that angle D would have to go with angle Z. Alright, and if we look at the side lengths, AB goes with WX, BC goes with XY, CD goes with YZ, and DA or AD goes with ZW or WZ. So there's our first example, looking for corresponding parts. Alright, the second part says determine if the polygons are similar. So they have to have the same scale factor for all the parts. And of course you have to have the same angle measures for all the parts. So if so, write a similarity statement and give the scale factor. If not, explain. So let's just look. If we're looking from the left one to the right one, scale factor from here to here would be 4 to 8. Well, or 8 to 4. We're going to just do a 4 to 8 right now. And we're going to say, is that equal to the scale factor of 10 to... Oh, sorry. Ooh, I made a mistake. And that's a common mistake. Those are not corresponding parts. Look at that from the picture. It has to be 4 to 3. We're wondering, is that congruent to 10 to 8? Well, 10 to 8 reduces to 5 over 4, and that would be not true. So these are not similar. And if you explain it, it's because there's not the same scale factor. All right, let's look at number 3. We can look at corresponding parts again. Although it's no, I'm not sure exactly which parts go with which. If you can find them that they would work, that's great. Let's see if the angle measures work out first. So we have 88, so we know that 49 and 49 are congruent. So according to that, then, this one would have to be 88. So let's see, 43 plus 49. So 92. And that would leave 88. So this would be 88. Angles are all congruent. That's good. Let's just check the scale factors. So 6 would have to go with 9. So 6 is to 9. Let's see opposites again. So 8 would have to go with the opposite of this one, so it would be 12. Okay, so far those are the same. And then that would mean that 4, hold on now. Yep, 8 would go with 12, and 4 would go with 6. Let's just reduce those and see that this would be 2/3, this would be 2/3, and this would be 2/3. So yes, they are similar. They have the same scale factors, and all the angles are congruent. Awesome. All right, so there's some more examples. It says the polygons are similar in these examples. Find the value of each variable and scale and the scale factor. So simply, if you're looking at this, 8 is across from this angle, so 8 of 12 would have to be congruent to 9 to 15. So we can use our cross products property and do 15a equals 9 times 12, which is 96, I believe. And divide, what is it, 96? 9 times 12. Let's check this real quick. Oh, sorry, 108. I was off by 1. And we divide both sides by 15. 108 divided by 15. Not going to be perfect there. 7.2. So A would be 7.2. 7.2. With B, we'd have to do the same thing. We can use 9 over 15 again. Equals to 10 Actually, it'd be b over 10. Sorry. We do cross products, we'd have 15b equals 90. Divide both sides by b, you get b equals 6. Or divide both sides by 15, so that's 6. So we got the missing parts there. Um, and the scale factor there is 9 to 15, which would reduce to 3/5. Alright, so number 5 is a little more challenging. I'm going to have you try this one on your own and show me what you get next time. But we're given that these are similar. We're given that, so we'd have 5 goes with x over 1 and 8 goes with x plus 1. Sorry, x minus 1 and x plus 1. Still have to set it up and solve it that way. So we'll set it up. 5 is to x minus 1 as 8 is to x plus 1. Alright, and I think you can do this one. Alright, last section. We're given the similar triangles again. Find the following. Find the scale factor. Alright, we'll look for corresponding sides that we know are corresponding. OP is congruent to XY, so that would be 4 over 10, which would reduce to, oh, I guess if we're going to NOP, so it have to be opposite. It has to be 10 to 4 because we're going to the bigger, so it would be a bigger number, 10 to 4, which would be 2.5 to 1, I guess. So the scale factor is 2.5 times the size. A measure of angle Y would be the same as this measure right here. So whatever that measure is for you'd find for Y. And I'm going to let you try to find number 7 on your own. Number 8, NP. Again, use your scale factor. 2.5 to 1 is equal to 12 to NP. So for NP. And then finding NP over WY. So you'd have to make sure that that works out. All right, and it's the same as the scale factor once you find NP. I'll let you do that one on your own as well. There's one more example, and this is a good one, good challenging one. This one is a bonus if you want to figure it out and bring it to me on your own, and I'll give you a piece of candy for it. But this one says a company makes rugs. All right, their smallest rug is 2 feet by 3 feet rectangle. Their largest rug is a similar rectangle. If one side of their largest rug is 18 feet, what are the possible dimensions of their largest rug? So there might be more than one answer for that. All right. And finally, to close it up, there's an error analysis and one closing question. And the closing question says, what 2 conditions must be true for figures to be similar? And that is our section 7.2. So hopefully you understand now why I brought up this Zoolander reference of this miniature model. So looking back at your goal, I hope you learned something from that. We'll talk to you next time.